Hello, everyone, and thank you for joining today's webinar on community-enabled life cycle analysis of stormwater infrastructure costs, or CLASIC, the tool functionality and case studies. This webinar is part of the Water Research webinar series from EPA's Office of Research and Development.
Well, hi, I'm Ben Packard. I'm a grant project officer with the EPA Office of Research and Development's Office of Science Advisor Policy and Engagement, OSAPE. So I'd like to share a little bit about EPA's funding for this project. There's a fair amount in the literature on green infrastructure design, pollutant removal, and performance. However, not much information has been available about the costs of different stormwater approaches and ways to compare costs across those approaches. So in 2015, EPA put out a national priorities grant opportunity called National Priorities Lifecycle Costs of Water Infrastructure Alternatives. And the agency asked for research to develop decision support tools, methods, and models to assess green and gray infrastructure investment options in order to determine the most cost-effective approaches across the life cycle of investments. So final tools and models developed under the grants needed to be nationally applicable as well as scientifically robust, yet simple, usable, and understandable. In 2016, EPA awarded one of these grants to the Water Research Foundation to include researchers from Colorado State University, Wichita State University, University of Maryland, and University of Utah. The team has recently released the Community-Enabled Life Cycle Analysis of Stormwater Infrastructure Costs, or CLASIC tool. And so this is a new web-based tool that's already included in EPA's Green Infrastructure Modeling Toolkit. Communities can use the tool in support of holistic stormwater management and integrated planning efforts. So I've had the opportunity to work with the CLASIC team over the past 5 years as they've developed the tool. And one of the noteworthy aspects of the project has been their engagement with potential users through interviews and beta testing to gauge community interest and identify needs that could be addressed by the tool. So, you know, as you hear the presentation, I think you'll see that the effort is paid off. I think that the tool is very easy to use, and we hope that it plays an important role in helping communities make decisions with regard to stormwater infrastructure. So with that, I would like to thank the CLASIC team members for all the hard work over the last 5 years, and I will turn it over to Dr. Harry Zhang with Water Research Foundation.
Thanks, Ben. So I want to first thank you for the support from EPA and the Water Research Foundation on this effort, along with CLASIC team member and the national collaborating partners. So in my 5 minutes of presentation, I'm going to, after my introduction, I'm going to pass over to Sybil, who will talk about the CLASIC tool functionality, along with a demo. And then our CLASIC team member Tanya and Jenny are going to talk about the community engagement, along with an example of the case studies. At the end, we'll have a Q&A moderated by Ben. Next slide, please. So here's a list of the CLASIC team members along our national collaborating partner, Water and Environment Federation, American Society of Civil Engineers, and American Rivers. So this is a great team effort over the past 5 years. So we want to thank you for all their support. Next slide, please. So the Water Research Foundation promotes a holistic approach to stormwater management. At its core, it has 3 pillars. The first one is the performance. Second one is life cycle cost. The third one is the triple bottom line benefits. So CLASIC project is a great example that has demonstrated a holistic approach to stormwater management. Next slide. So just as a quick snapshot for you, so CLASIC tool can simulate both hydrological performance and also pollutant load reductions. The pollutant concerns in the tool include total suspended solids, total nitrogen, total phosphorus, and the fecal indicator bacteria. And then for the life cycle cost module, which is a core of the tool, it can simulate generate output for net present value, average annual cost over design life, and a unit cost. For triple bottom line benefit, the CLASIC tool can generate the score of the economic, environmental, social benefits based on user-selected importance factors. Next slide, please. Through the collaboration with the American Society of Civil Engineers, the CLASIC team was able to create a new urban BMP cost database, which is as a module to the existing international stormwater BMP database. Next slide. So this is my final slide. So the Water Research Foundation funded a companion project on quantifying and monetizing triple bottom line benefit of the green stormwater infrastructure. And I'm glad to let you know the Water Research Foundation has a new project on the comparison case study to start it on June 1st, 2021. So please stay tuned for further information. With that, let me pass back to Ben.
Thanks, Harry. So now we'll transition over to Dr. Sybil Charvel, and she is with the Colorado State University. So Sybil, I'll turn it over to you.
Thanks, Ben. And thank you, Harry, for the introduction as well. Okay, so we got a brief introduction of the CLASIC tool from Harry Zhang, and I'll kind of continue that and get a little bit more in depth on how the tool works and the intent of it. And so this is our vision for the CLASIC tool, which is really intended as a high-level screening tool that supports stormwater infrastructure decisions on extent and combinations of green, hybrid green-gray and gray infrastructure practices. So looking at all sorts of stormwater control measures and their applicability. So it's really intended to be applied at a larger scale and again, inform these kind of higher level screening decisions. And after a user has used CLASIC, they may decide on types and extent of stormwater control measures and then move to some of the more detailed design tools like SWIM or National Stormwater Calculator. Oh, sorry. Okay, so as was mentioned, there was an extensive community engagement effort associated with this project. We engaged with potential users of the CLASIC tool to form the vision of the tool, to develop what would be useful outputs, and then we developed a beta version, which was then tested by potential users of the tool, and ultimately have delivered what we feel is a very user-friendly tool. The tool is web-based and is GIS-interfaced, so it has automatic collection of data from national data sets with options to also upload more local data sets if a user prefers. But a user has the possibility to run the CLASIC tool using these national data sets without having to input a lot of their own data to kind of inform some of these high level decisions. And the URL for the CLASIC site is listed here. And on that site, you would create a login. There's a button to create a login, and you create an account, and then it saves projects. Okay, so the questions the CLASIC tool seeks to answer. How do various scenarios of stormwater infrastructure compare in terms of life cycle cost, pollutant volume reduction, pollutant removal, or runoff volume reduction, sorry, pollutant removal, social and environmental benefits? How does climate change and land use change affect future performance of these different scenarios of stormwater control measures? Really wanted to be able to look at future scenarios with the CLASIC tool. And how do maintenance and long-term costs compare for the selected scenarios that a user is looking at? So CLASIC enables users to assess scenarios of stormwater infrastructure for regulatory compliance, runoff volume reduction, a lot of these benefits we've already talked about. The idea is that then a user can couple financial decisions with these holistic considerations of benefits. and allows analysis from the neighborhood to watershed scale. What CLASIC wasn't really designed to do was site-specific design of stormwater infrastructure. So like I said, it's really intended, CLASIC is intended to inform these high-level screening decisions, and then a user may move to some of the other existing tools for more detailed site-level design of stormwater control measures. Comparison of spatial distribution of infrastructure within a subunit or catchment, and it does not include algorithms for optimization of designs. Rather, the tool is designed so that a user sets up multiple scenarios and compares those scenarios with respect to the hydrologic performance, cost, and co-benefits. So these are the steps a user would go through when using the CLASIC tool. They'd select a study area, and then we have these uploaded national data sets. Select climate data stations. They have a potential to modify default parameters and build scenarios. Then they would select importance for co-benefits that would like to be assessed, set any targets related to hydrologic performance, pollutant load reduction, or cost, and then run the tool and be able to view outputs. Here's a list of technology categories that we've included in the CLASIC tool. So we have rain gardens, sand filters, infiltration trenches, permeable pavement, green roofs, disconnection, grass swales, extended detention basins, wet ponds, stormwater harvesting, and storage tunnels or vaults. So you can see here a possible combination of green and gray infrastructure across the spectrum. And this is a brief screenshot of the summary page output for the CLASIC tool. So the CLASIC tool provides inputs in these outputs in these three primary categories, including cost, co-benefits, and then the hydrology and water quality components. So a user compares the different scenarios. They can look at 3 scenarios at a time. And this summary page shows some of the life cycle cost estimates, including construction, maintenance, and rehabilitation. Results from the co-benefits analysis, where they get a score in each of the social, economic, and environmental category. And then the bottom component shows the hydrologic parameters related to runoff, infiltration, and evaporation as a change from their baseline condition. So then a user can select to see more detail on any of these different categories of outputs. Okay, so here's these 3 basic outputs again. And we have, again, the performance, life cycle cost, and co-benefit analysis. So I'm going to talk a little bit about the performance in terms of water quality and hydrology, and how the CLASIC tool works to provide those estimates. So CLASIC does interface with the EPA SWIM model. And so basically we have modules of SWIM that are used to interface with the CLASIC tool. So all of these input parameters that are defined through these national databases, or that the user would like to modify or use local sets, are used then as inputs into a SWIM file. And then the SWIM file, or the SWIM model, is ultimately run, and then output is provided back to CLASIC. So the user does not interface with SWIM. That all happens in the background, and the CLASIC tool has an automated way of generating the inputs that are needed for the SWIM models. Okay, so a user adds stormwater infrastructure by selecting the type of technology. I provided that list of technologies earlier. This is an example of the rain garden application, and a user would pick from a small, medium, or large application of a rain garden, for example, or whatever technology they're looking for, and have different selections on specific design components that may either impact hydrologic performance, co-benefits, or cost of the technology. And then the size of the technology is important, because a technology unit treats a specific volume or area that is defined within the CLASIC tool. And essentially, when a user picks the size of the of the technology that they'll add, the tool then automatically generates how many of those particular technologies at that size would be needed to treat the volume that the user is inputting. User also has the potential to build these climate scenarios. In addition to looking at different technology, a user can look at different future scenarios for climate as well as land use. And I'll go through an example of the land use in my demo that I'll be going through. So there's two options for climate. One is that a user first selects the climate station from which that they'll get data, which is typically somewhere close to the area that they select in the tool. And then they can look at future scenarios and can potentially look at changes in precipitation and evaporation that would potentially be expected over a future condition. So in this case, on this left side, we're seeing a 15% decrease in precipitation and a 10% increase in evaporation. And we can look at different percentages of increases or decreases from the kind of baseline climate model. The other option is to use CMIP-5 climate models, and the user here can select a climate model that they would like to assess. So there's these various different climate models that have been developed and downscaled. So we have middle, warm, wet, dry, and hottest. And a user can select those different types of climate models, and then they would also select a representative concentration pathway, and that represents kind of the degree of mitigation we have for climate change. So RCP 8.5, for example, represents a low mitigation strategy with a lot of climate outcomes. Then the user would also select what future year that they're interested in looking at. So that relates to the performance component of the tool. They'll hear more about the life cycle cost component later in the presentation. So I'll also be talking a little bit about the co-benefit component. The co-benefit analysis in the CLASIC tool, again, relates things to environmental, social, and economic indicators. And these are the broad categories of indicators that the CLASIC team has developed that are based on these kind of integrated urban water management indicators of sustainability. So we have things like species diversity, green space, jobs, the potential for outreach and education. Those are all examples of the various indicators that are included. This just goes through an example of some of the indicators that are included in the economic category. So for example, here we have property values, costs from illness, avoided costs from combined sewer treatment. And the CLASIC tool makes use of either inputs from the user and selections on technologies to estimate these, or outputs from the tool in terms of volume reduced or water quality benefits. So it's really making use of the quantitative measures that are output from the tool or that a user would select, like the up here, for example, for property values, we use stormwater control measure area and acreage. So that's a user selected based on the number of technologies that a person would add, or a user. Okay, so now I will get to the fun part where I'll demonstrate the tool and how it works. You've seen these steps, so we're going to now be going through all of these steps that the tool offers. And like I said, there's at the home page for the tool, you'll find a place where you would log in, and then you would start your project. And you create a project, and any project created would be saved again when you go to log back into the tool. This kind of left panel over here on the side of the tool is a step-by-step guide of the steps that a user will go through to get through to the outputs of the tool. So the first step is to either select a project or create a project. In this case, I've selected to draw a rectangle to build a project, and this project is in Carmel, Indiana. And this is an area of Indianapolis that's undergoing a lot of redevelopment. And so I just selected a rectangle there, but there's many other ways that you can select areas that you would like to look at, including uploading your own GIS layer. And then we select the project subunits. So in this case, I've selected tracks. So if you see these divisions of this area selected and the numbers, those are the census level tracks that divide the area into subunits. This enables a user to employ different technologies in different areas, or to look at different land use changes in different areas and kind of do a subunit analysis. If you're just interested in looking at an area as a whole, then you would select just one subunit to look at. Then the tool makes use of NLCD and Surgo data for land use and soil data. So after these selections are complete, then the user creates a project, and the tool automatically uploads again all of those different data from national data sets into the tool, so that those serve as the inputs then into the SWIM file. A user will also select precipitation and evaporation stations. So those nearby stations will automatically populate, and the user can select which station that they would like to use. So here we're looking at the evaporation data, and Linwood Farms is the name of the station that you can kind of see up here to the right of the project selected area. Next is the default parameters. These are all automatically uploaded into the CLASIC tool. Some of these default parameters are default parameters that the CLASIC team set as practical or realistic estimates of the parameter estimates. Other ones are ones that are uploaded from these national data sets. So the user can modify the default parameters, or they can completely skip this step and decide to move on and use only default parameters. So they can go through a very quick simulation using the CLASIC tool. However, these are the categories a user could select to modify, including water quality, overland flow length, some of the infiltration parameters, technology influence, and some assumptions related to life cycle cost as well. Okay, so the next step is that a user will start to add scenarios. So in this case, I'm developing a scenario called redevelopment, which is going to represent a redevelopment area where we'll have increased impervious area as a result of some new development that would potentially come into the community. So the way that that's represented is that then in this redevelopment scenario, we go into the land use category here, and we can adjust imperviousness area, adjust subunits imperviousness by, say, 25%. So over here in this table to the right, these values are all now blue, indicating that they've been modified from the original data set that was uploaded from National Land Use Category, the NLCD database. So those are all increased by 25%, increasing the development of the area. Okay, so then as an additional scenario, we can look at, okay, now we have this redevelopment area, and now what if we add rain gardens into that area with the intent that we would like to achieve the hydrology that was present before the redevelopment occurred. Okay, so here now again, we can select all these different categories related to the design of the system. I've selected large rain gardens. I've selected some of these categories like requires. We're going to have seed as the vegetation, and we'll have routine mowing required, which will impact the cost of the projects. The next step after a user creates scenarios is to look at co-benefits. If a user's not interested very much in co-benefits, they could just leave these selections as they are. If a user is interested in these, then they might want to change the weighting of these different indicators. So, or select on or off different indicators. So a user here can select the importance of each of these indicators. So we have over here least important to highest importance with the number of blue bars indicated. And then a user can then select on or off different ones. So for example, here we have potential impacts from nuisance floods as being not an important parameter to look at or for the co-benefits in this case. The user can also set these targets related to pollutant reduction, runoff reduction, or cost. And I've shown this before. This is the summary page that one can look at, and you'll see more about this this Carmel study because this is one of the case studies that Tanya and Jenny will be talking about later in the presentation today. So we have here again some general information about the life cycle cost, the co-benefits and the hydrology and water quality. So in this case, we're selecting these scenarios. We have the redevelopment with rain gardens, and then redevelopment with green roofs. So in the case of redevelopment, we didn't add any new green infrastructure or stormwater control measures, so there's no cost indicated with that scenario. Then we went in and added technology, so you can see the rain gardens are lower cost than the green roofs, but just quickly looking down here at co-benefits, we can see that the environmental, economic, and social benefit scores for the green roofs are higher than that for the rain gardens. This shows some of the hydrologic data, again, from that summary page where you can look at a percent change from the baseline in each runoff, infiltration, and evaporation. So we can see, looking on the far left here, the redevelopment scenario, we can see that there was an increase in runoff, indicated as the blue bar, from the baseline conditions. So adding that impervious area resulted in increased runoff and evaporation in the system, in the area. And then what we see is that by adding rain gardens, we decrease to some degree the runoff, and then we get a little lower decrease from the green roof. So the rain gardens are more effective to reduce runoff. And we could keep adding more technology until we get this back to a 0% change in the runoff from the baseline condition. Here are some of the cost output parameters, so we can look at, again, that construction, maintenance, or rehabilitation, present value cost, or we can look at the average annual cost over the design life. And then this looks at some of the co-benefits that we can see here. So for example, we have social and economic and environmental scores for each of these different scenarios. So the social shown in blue, orange and economic, environmental in green. So we see that the green roofs add a lot of benefit, and we can start to see exactly in what categories those are doing very well. So here we have the social benefits selected, and we can see that, you know, health impacts from water, from air quality, mental health from aesthetics, public awareness of stormwater systems. Some of these things are doing much better in the green roof category than they are for rain gardens, although rain gardens do offer some of those benefits as well. And then here we have some more detail on the hydrology and water quality. So we have these different scenarios and percent change from the baseline. That kind of goes through the different outputs of the CLASIC tool, and we'll see some more of these kind of outputs as we go through the case studies later in the presentation. So thank you, and I'll pass it on now.
Great, thanks, Sybil. Great presentation. And one thing I just want to highlight how easy it actually is to use. And I know Sybil mentioned this, but there's a lot of data that's pulled into the model in the background that you don't actually have to worry about when you're working on this. So there's all those national databases that just automatically are pulling local information into that model. So that makes it really easy to use. So I'll go ahead and transition to the next set of speakers. So as I mentioned, there's a strong community engagement component to this project, and Jennifer Egan and Tanya Brownlee are with Maryland Environmental Finance Center and Wichita State University Environmental Finance Center. So I'd like to introduce them, and yeah, so I don't know if Jennifer or Tanya is going first, but I'll turn it over to you.
All right. Thanks, Ben. I'm going to kick it off and then pass it off. Jenny and I will bounce back and forth. So when you start a project like this one, the technical piece, the data, the tool you're developing is the real superstar. However, none of that would be very useful if you weren't engaging the potential stakeholders or the folks that are going to use it to find out what they need so that the tool is right for them when it's time. So that's why we really infused community engagement throughout the development of CLASIC. So we did a variety of things. We did interviews, reached out to various communities of various sizes, different folks in the stormwater biz, contractors, municipalities, rural water folks, all sorts of folks we reached out to, interviewed to find out what the drivers were for their potential engagement with CLASIC. These are the folks we reached out to. We made sure that we represented all 10 EPA regions, and we interviewed 24 communities. We found out, like I said, the drivers, what's going to drive them to use the CLASIC tool, what common practices or technologies these folks wanted to know about and include in the tool, and then what types of financial information is going to be best for them to have built into the tool so that then they can make good decisions for their own projects moving forward. Jenny?
Thank you, Tanya. So one of the things that stormwater planners need to do is to assess their programs and departments and then identify, what practices are practical. So within the municipal systems planning for stormwater, this tool helps to determine which practices might fit into their budgetary needs. So this just shows the cycle of budget planning for stormwater, and that CLASIC can help in this budget planning. Next slide. And part of the guidance documents we have prepared is to discuss the different types of funding sources that are available for stormwater, and how CLASIC tool again helps estimate a high level funding and determine those trade-offs between different types of practices that might be available for stormwater planning. Next slide. I think it's back to you, Tanya.
All right. So the second step in our community engagement process were these user stories. So user stories are what the tech field uses to help inform those folks that are developing the tools about what the audience wants or needs out of the particular thing that they're developing. So we again made a bunch of phone calls. We reached out to folks and came up with about 20 user stories. So again, we tried to meet each EPA region, and some examples of our user stories are, as the stormwater superintendent, I want to understand the cost to maintain my green infrastructure so that they can educate management team, residents, and businesses on the value of green infrastructure in the community. So that's what a user story is, and those stories helped Sybil and her team develop the CLASIC tool so that it meets these needs of the audience. So then after we had these user stories, then the tool developers, Sybil and her team, built CLASIC, and then we did some beta testing, and folks, we had 34 beta testers from across the nation, and we had them test the tool, give us feedback. How did it work? What parts did you like? What didn't you like? When do you need definitions? When, what parts tripped you up? Got all sorts of great feedback from these folks of all different varieties, and then just went back to the not the drawing board, but we went back, made adjustments, and updated the tool to meet those feedback that we did get, and then we had a tool that was ready for case studies. So then we reached out again to our community and said, our stakeholders, and said, hey, use this in your real world. How can this be helpful? You know, plug in your real world scenarios and let's do some case studies. So then we ended up targeting our case studies, making sure that all NOAA climate regions, all 9 NOAA climate regions were represented, and making sure that as many EPA regions were represented as possible, making sure, again, that we hit variety of community sizes. We had varying levels of case studies. So we had some smaller targeted case studies that focused on specific features or uses of CLASIC. And then we did some in-depth case studies, really taking a deep dive into using CLASIC to develop, larger plans for a community on new development, redevelopment, and then some targeting approaches. One example, so, Sybil showed us the Carmel, Indiana example, and that's one of our case studies. So again, that target area was selected. We got some life cycle cost analysis completed for that scenario. So if cost would be the only criteria, you can see from this slide that, we're going to choose the detention basin if we're only thinking about cost for this scenario for Carmel, Indiana. However, if the community is more focused on something like decreasing runoff, then maybe we're going to be looking at the rain garden. And then again, if you're trying to think about overall sustainability or long-term avoided costs of combined sewer treatment, which is this green bar here, maybe you're looking at a rain garden scenario. So CLASIC can really help decision makers and the more technical folks really combine the needs and wants of the community to figure out what scenarios might be best to institute in the selected project areas. So it's a really useful decision-making tool for communities as they think about stormwater infrastructure development. We've got a variety of targeted case study topics. We even have a couple on climate resiliency, and like Sybil showed you, you can adjust climate scenarios and use those to inform some different scenario options.
Great, thank you, Tanya. And so you've seen how the tool works basically, and we did do all those case studies. One of the in-depth case studies was with Philadelphia, and really, as many of you know, they're very far ahead on their stormwater implementation. But we wanted to take a step back and say, how can CLASIC help with their future planning, and even to try to assess where they are with how green is green. They wanted to understand in a particular neighborhood or in a particular planning area, if they need to justify greening and the costs associated with greening, how can they do that, and how can they communicate it? And what are these trade-offs of cost and benefits with the subsurface features that are less green versus putting in more green infrastructure? Next slide. So we had a study area, and as you can see, it can be broken down into block groups. So you can get smaller scale, but like we've said, it's more of a planning tool this is about 90 acres. Next slide. And the progressive greening. So as with a lot of municipal and urban areas, the underground storage is less green. That's your grayer scenario. So from scenario 1 to scenario 3, we just wanted to profile what it looks like to just have the underground scenarios versus progressive greening. So the third scenario, we really put in some diverse vegetation and trees to show not only the costs, but the benefits of that progressive greening. Next slide. And so you've now seen the output and summary slides as Sybil has shown them and Tanya has shown them. But again, this is going from grayer to greener, and then the middle one is like a hybrid where you have different pollution reductions, different runoff reductions, different infiltrations. So you can do those trade-offs where you say, okay, we're reducing runoff, we're reducing pollution, each relatively equally. Scenario 2 and 3, you do get the infiltration and you get a little bit more of the evapotranspiration because you do have the green infrastructure and those rain gardens instead of just the infiltration trenches, which is scenario 1. Next slide. And then the cost as well. So you can see with progressive greening, as people say, yes, it may be more expensive, but how does that, the life cycle cost is built in to say, how does that change over time? What are my average annual costs? Your average annual cost might be slightly similar. So again, this comes back to the budgeting. How do you think about budgeting long-term when we know that these are maybe 30-year projects and you might be funding them and financing them in certain ways, where if you take the life cycle cost approach, you make the decisions a little bit differently. Yes, the $2 million infiltration trenches may be cheaper, but over the long run, and you want to start to think about those co-benefits, the $4 million budgeted and financed in a certain way might be the selection that you want to make. I want to also mention that the University of Utah, Christine Pomeroy, did an excellent job of the cost buildup for these life cycle costs. So when you can select the study period from up to 50 years, Christine did a line item buildup of multiple different types of technologies. All of your technology selections you can make are done by line item cost buildup. So it's very detailed cost, and it is regionalized. So you, depending upon the region you are, there is an adjustment for these costs. Next slide. And here's, again, the scenarios just determining from construction to rehabilitation. Rehabilitation just takes a portion of that construction cost and says, within a certain amount of time, you're going to face some rehabilitation. But then you also have the annual maintenance costs that include labor to materials, again, in that line item buildup. And you can see the total cost over 30 years. You have the option to add a discount value as well, which the guidance manual describes why or how you might want to add a discount value when you're doing these life cycle costs over different time frames. Again, here's the average annual cost. It allows you to see, like, over a 35-year planning horizon, what are your average annual costs? And then you can calculate the dollars per gallon. In this case, it's dollars of runoff reduced per gallon. So next slide. And like Sybil indicated, the co-benefits part is part of what this tool helps to begin communicate. Why do we want to do this progressive greening? What's important to our community? If we select economic indicators, social indicators, environmental indicators based on what's important to the community, what's maybe important to this neighborhood, maybe there's no trees in this neighborhood, and the importance of greening this neighborhood is important relative to other neighborhoods. So you do select those indicators to then again compare. You can go to the next slide, Tanya. Compare and show different decision makers, different departments, different people that care about what stormwater does for the community. You say, okay, if we do this underground infiltration, that's scenario 1 on the left, sure, we get some co-benefits. But if we start to put in the green infrastructure, we have this higher relative co-benefit score, and it helps describe visually what this means. The dials say that we get more benefits if we put green in that third scenario, where we have diverse vegetation, pollination, trees, and greening of the area versus, again, just the subsurface features in scenario 1. Next slide. Okay.
And then we just, this is our marketing part. The last part of community engagement is marketing, like we're doing now, getting the word out and making sure all the stakeholders that could use this tool across the US know about it. So I'm going to pass it back for the Q&A session.
So thanks again to all the presenters for that great presentation. A reminder that this was recorded and will be posted on the Water Research webinar webpage within a week or two. And please join us for our webinar next month on June 30th, which is the approach to track chemical mixtures in urban waters impacted by road salts. Thanks so much.